Okay, so we're looking at finding the lowest common multiple and the highest common factor using prime factorization. This time we're doing a slightly harder question with slightly bigger numbers. You need to be confident with what we mean by lowest common multiple, highest common factor, and also how to carry out prime factorizations. Okay, so I'm going to make a start straight away. The first step is to do prime factorization of our first number, 144, and prime factorization of our second number, 280. Okay, not forgetting that we're trying to find the highest common factor of both and the lowest common factor of both. Here we go. So 144. Should be happy that is a square number. That is 12 times 12. Okay, 12 is not a prime number, so we can't stop there. 12 is the same as 2 times 6. 2 is a prime number, so we can stop there. 6 is the same as 2 times 3. 2 times 3. And we can do the same for this 12. Works exactly the same. So we've got 2 times 6 and then 2 times 3. Okay, so we can write 144 as a product of its primes, and that is 1, 2, 3, 4. So it's 2 to the 4 multiplied by, oh, that 6 shouldn't be circled, ignore that, 3 squared. Okay, not forgetting that this can be written as 2 times 2 times 2 times 2 times 3 times 3. Okay, all of these statements are identical. They mean the same thing. Let's do 280 next. Okay, I'm going to say that this is in a 10 times table just to make the numbers a bit more manageable. So that's 10 lots of 28. 10 is 2 times 5. Both of them are prime. 28 is even, so let's take a 2 out, leaving us with 14. 14 is 2 times 7. So there we go, we've finished doing that one. Let's write it out how we have here. So you've got 280 as a product of its primes. You have 1, 2, 3 lots of 2, so that's 2 cubed, times, we've got 1, 5, and 1, 7. Okay, and again, don't forget this can be written as 2 times 2 times 2 times 5 times 7. Right, next comes the Venn diagram. So let's draw our Venn diagram. Make it nice and big. We're going to have one circle to represent all the prime factors of 144, and one circle to represent all the factors of 280. Okay, you'll notice my circles aren't perfect. This is just working out. If it was a diagram and there were marks in drawing the diagram, then it would be worth doing them accurately. But as I said, this is just working out. So as long as you can read it and it's clear, that's fine. Right, so first of all, let's do all the things that they have in common. So they both start with a 2. So we can put the 2 in the middle. Then there's another 2. Another 2. This one's got another 2, this one hasn't. This one's got a 3, this one hasn't. This one's got a 3, this one hasn't. Okay, so there's no more we can write in the middle. Right, so the rest of the prime factors of 144 go in this area here. So we're left with 2, a 3, and a 3. And then the rest of these, so that's 5 and 7, go in this one here. So that's 5 and 7. Cool, so first of all, we're going to do the highest common factor. And if you remember, the highest common factor is the same as all the numbers in the intersection multiplied together. So that is 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. That's our highest common factor. Next up, let's do our lowest common multiple. Remember, this is the union. Black union. All the numbers in the union multiplied together. So we've got 2 times 3 times 3 times 2 times 2 times 2 times 5 times 7. Okay, so a few ways you can think about this. That all multiplied together must give us 144, and that all multiplied together must give us 280. So you can pick which one do you think might be easiest to work with. I'm going to say that this here is equal to 144, and this 5 times 7 is 35. Okay, so you multiply them two together. Let's do a quick Napier's method. So you've got 144 along the top and 35 down the side. Draw on your box. So all I'm doing here is multiplying these numbers together. If you use a different method, as long as you come to the same answer, that is fine. Okay, so now let's quickly do this. You've got 3 times 4 is 12, 3 times 4 is 12, 3 times 1 is 3, 4 times 5 is 20, 4 times 5 is 20, 5 times 1 is 5, add these up is 0, add these up is 4, add these up is 10, add these up is 5, so this comes to 5,040. Okay, so that's 5. These numbers give you your answer.